Okay, so today we will continue on from last week and keep talking about basic C. Last week we talked about the main function, we talked about the return value, we talked about the basic variable, we talked about the basic syntax, we talked about printf, scanf. Now let's dive a little bit more into this include things that I mentioned last week. All right, we call this the preprocessor. Preprocessor basically are additional information on your code. It's the additional information you give to the compiler that includes things like the header file. The header file usually contains function definition. So in this .h file or list of functions, it contains the list of functions. Most of the time, what will happen if it's a legit function that has been implemented and is available somewhere on your machine, then the header file will allow the program, your program, to call that function. For example, when you implement hello world, right, the program, you call printf. Let me ask this question. Who implement printf? So when you download, yes, sorry. Go ahead. Yeah. Who implement printf? You call the function printf, right? And obviously, from your main function, somehow it knows what exact function you have to call and what's the code in them, right? First of all, it means that the library has to be installed and you can call that. Someone implement printf and your program can call the function. Then the header file, which is the standard.io.h, as we saw earlier, has the definition. Say, hey, printf is available. You can call, and here's the format. Put in the string, it prints the string. Just pound define will basically replace the text as is seen with another text. And you can do a bunch of things with the pound symbol. When you have a complex code, you can check if this thing is defined before. If it is defined before, don't define it. Don't like make double definition. If it's not defined, define this to be this something else. Then the compiler follow the step by tokenizing your file, your program, basically. When I said tokenizing, it means that it tries to understand your code. This is what your code is doing. Then prepare this information for the compiler to then optimize your code and spit out assembly. All right. Again, the goal is for the compiler to take your code and somehow spit out assembly. One of the first steps is to look at the preprocessor and see what are the different function calls that your program are making that I have to gather so I can run those functions. Then I tokenize the file so I know more about what the program is doing. Then I compile them into assembly. So here's a header file. You include the function definition of your for your program. You can also include the actual code that you want to leave out of the main.c file, right? So basically your code, most of your code will be in the .c file. But for example, you have a really simple function called add, which takes two input A and B and return A plus B. You can put that in a header file, it's okay. Basically, the whole reason why you are doing this, the whole reason why you're doing this is to make sure the main.c file is not attacked. Things that doesn't have to be like people doesn't have to be worried about, but you need the definition. It's in the .h file. Say these are functions you can call. Definition can be in the .c file or in the .h file itself. It also have pre-built function like stdio.h or standard library stdlib.h. These are pre-built for you when you download the build essential, when you install GCC. This comes as a part of that. You can also include install libraries. Let's say you install more things for more fancy C++ or C libraries on your computer, then you can include that. Then the pound define, we call this the macro. Think of it as whatever you put there, you replace the search term with something else. For example, I can say pound define debug one. What it does is the compiler will then go through your text, the code in text form. If it sees any occurrence of debug, replace that with one. For example, I can then do this. If debug what would this allow me to do? Basically, it means that I can always just flip this from 1 to 0. If I flip to 0, this thing will not get print. If that is a 1, it will print that thing. That actually can be pretty useful when, how many of you write Python code and print things out when you want to debug your Python code? Yeah, we do it a lot, right? So what if you want the submitted version to not include that at all? Just to pound define debug one, and all the printf can still be there. You do if debug, right? Then you change debug to 0 when you submit the code. You can keep it there. It will not get print, right? Because the debug definition would replace to 0. If 0 means that I'm not doing this. It's if false. There's a lot of macro and fancy things you can do. You can even do things like build a macro to run some simple function like minimum of A and B. For example, it can take arguments like this, right? I can do pound define min of A and B, and I replace this whole thing with this guy. So it means that I'm going to search the text. Every time I see this min of A and B, and A and B, C knows that A and B can be anything. For example, min of 5 and 10. Min of 5 and 10. In this case, we'll do 5 less than 10 or not. If yes, 5, or if no, return 10. This is a syntax. Basically, the syntax is this: something, some condition, the question mark, x colon y. It means that if the condition is true, return x. If the condition is false, return y. It is the same as if condition, return, if condition, x, else y. All right. This is called function-like macro. So you can check the link as well. For the purpose of this class, you don't need this at all to finish the assignments. But you might see this when you read some other people's code because we use this quite a lot. You can also build the macro like an object as well. Again, check the link. And then that's the one I recommend, Pitfall with macro, because at some point of time, I mean, some people might want to be fancy with macro, right? But there's also pitfall that you want to avoid. Don't use macro for these scenarios. So you can check that one as well. All right. Any question on preprocessor before we move on to arrays?
For the step define.
Yeah.
For like the example of the debug, is it case sensitive or not?
Case sensitive, yes, a great question. So it's case sensitive. So if the reason, to be honest, right, the reason I typically do all capital case debug is I never write a function name that way. It actually make it safer so that I don't accidentally type in like lowercase debug anywhere and it accidentally replace that. All right. How many of you guys used array before? Good. All right. We use it all the time. You know how it works. What is an array? Huh? So in this class, we'll actually separate the concept between array and a list, actually. array has a fixed size, you can store things in them. You can store things in an array, has fixed size. Everything in the array has to be the same type. If it's an array of int. All right. It's a collection. Sometimes we call it a collection of data that has the same type. When you use the array, if you somehow be able to zoom into the memory, it should be next to each other. It should be next to each other. So the first item will sit next to the next item, will sit next to the next item. All of them will sit next to each other. So that's an array. Yes.
So to extend the array, will it be continuous to the memory or will it be somewhere else?
Still continuous, but the way you extend it in C, in reality, when you use the array, it's going to be looking a little bit different compared to Python. Python will handle that for you. It looks automatic. In C, you have to manually. So what you need to do? In C, if you want to extend the array, you make another bigger array. You copy everything from the first array to the second array, and then you get rid of the first array. The other difference between array and list, a list, each item doesn't have a way to sit next to each other. The first item can be here, second item can be here. You just need to make sure that it knows from here, it jumps to here. And we have a mechanism in C for that. All right. The way you implement the key thing with the list can be extensible. I can add things to my list. I don't have to copy the whole thing again. All right, so that's a trade-off. To use an array, you can use this bracket to specify the array of certain type. For example, int I10 means that it's an array of integer that can contain things like 1, 2. Right? So basically, it will initialize, and in this case, I10 is an array with 10 room for the item. Then you can assign the value later. Depending on the version of GCC and the compiler, sometimes this is initialized to 0, sometimes it's not. All right, so do not assume that it's always going to be 0 and in the beginning. Okay. Char A20, that's a string. Why? In C, there's no string. There's no such thing as a string data type in C. In C, when you think of a string, it's an array of characters. Why is that okay? I mean, yeah. Yeah, I mean, if you think about it, a string is just a bunch of characters one after another, right? So you think of it as an array of characters. So let's say I want to represent the letter cat, the word cat, right? How many alphabets are here? 3. I can put that into A. That has the room for 20, right? Let's say I want to print this out. Let's say I want to print this array out, which means I want to print out cat on my monitor. How can I tell that, hey, it ends at the letter T? Because if you look at it, right, my array can look like this. Basically 20 boxes, and the first C, A, T, right? And there can be something here, like some random letter that I haven't initialized. How can it know when I want to print this array, it stops right at the letter T? Okay, so your solution is when you want to print something, make another array and copy just the letter. But how can I tell that this is not a part of my word? Right? So the solution in C is when you end the string, you insert a null character, which is the value 0. So it's like alphabet, and it reads 0. And like, okay, that's it. That's your word. Anything can go after. So in this case, if I want to store the word cat, C-A-T, I cannot use a character array of size 3 Why? I need the last. Then it doesn't know the end because I need the last room for that 0. So I need CAT0, right? If I use just the array of size 3 and you try to print it out, it will keep going. Printf will keep going until it finds 0. And it will stop. So one common thing that you might run into for your assignment too is when you print a string, you might have a question. Why does this keep having this weird symbol after things I print? Yes.
The same thing for like there have to be the.
Oh, okay. So for the int, so the whole reason why we need to have the now, we call this the now character, the value 0. The reason why we need a now character is printf support string. Printf support this thing called %s, which print a string, which means that if I throw in the character array for my string, it needs to know when to stop, right? For integer, it doesn't have that. So integer doesn't have that requirement. It can be of any size, if you will. There's no ending. The ending ends at the total size of the integer array. So usually when you maintain integer array, and if you have to like make it shrink or get bigger, one common technique is you allocate a somewhat bigger array to make sure everything will fit. Then you have another variable that keeps track of the current size, so it doesn't go over the size. That would allow you to make sure it's inside this integer array. All right, so that's the array. The next concept, actually we're almost done today. We'll go into coding part. I'll be here until 1:30. The next concept is a data struct. Because what we learned so far, we can use integer, we can use float, use double, double, we can use character, we can use long integer, right? That's kind of limited. You should think about it. That's it. It's not a lot, right? Sometimes you want to be able to handle a data that consists of, for example, I can have my national ID, right? Along with my name as a simple thing, like simple one item that has both national ID and name. How can I do that? Obviously, I can use an integer for this because it's a number, right? Then I can use a string, which in this case is a character array, right? Data struct allow you to build this. Data struct, think of it as I want to combine these things together into one single item. Okay. And basically the key idea is it allows you to combine multiple elements into one single unit. We call this a struct. We call this a struct. Sorry about this, it's lowercase f, all right, lowercase f. So the way you use this is you do struct some name inside is a definition of your struct. Definition of your struct. Then you can then initialize, right? Let's say you want to use it. You can do this. So these become the data type. These become my variable name. So the data type is struct some name. Whenever I refer to the data type struct some name, it's always this type, integer followed by floating point. Then the name of my variable is, in this case, my struct. All right. I don't use it this way. I can then use my variable name, my struct dot a to refer to the integer elements. Then my struct dot b to refer to the floating point element. And the way this whole struct would look in the memory, when you put that in the memory, basically you have a followed by b, like literally next to each other. This whole thing come in chunks and just go with whatever order you put in the struct. All right. You can then build an array of struct. Okay. As used, it's similar to a typical array. So let's say again, you have a definition of struct some name, right? Earlier, integer and floating point. Integer is A, the floating point is B. So you can do struct some name ARR underscore name 1000. It means that I create an array 1000 element. Each element is struct some name. Then I can refer to ARR underscore name 0.a means that I want to get the integer element of the first item, and I can keep doing this. In the array, each struct will be one item. Each struct will be one item. So basically, one item has one integer, one floating point. Now, you might have seen that. Why do I have to keep typing this? It's long. I don't want to type this all the time. It's kind of annoying, right? You can use the function, a command to redefine the data type. We call this a type def. Type definition followed by the type that you know with the new name. In this case, I can do type def struct some name. Now the computer will know that whenever I see new name, is struct some name. Yes.
So if you have a way of struct, how do you like provide things? Let's say you have 1,000 names.
Yeah.
You want to go through one by one.
So you combine with the loop. Basically, you do this for, right? I equals 0, I is less than 1000, right? And then I plus plus. And let's say you want to initialize everything to 0, right? You would then do if ARR underscore name, right? I dot A equals 0. You can loop this way. Basically, now in that case, for every single element in my array, the eighth element in the list becomes 0. So you can handle it that way. In most, for example, one of the possible scenario that I can think, right? For example, I want to maintain the national ID and name, like integer and string, right? And let's say I want to have a new name. Basically, then I search my struct for my national ID and then update the name. Then I can loop through using the national ID to search, right? Obviously, that's not the most efficient way to do that. We have other methods to quickly do this, but yes, that's a possible scenario of handling this kind of data struct, right? All right, so that's it for the lecture material. One quick thing that I'll do, I'll split the recording so that I have the lecture part and the demo part. All right, so I'll stop the recording. Let's do a quick break and then we'll come back. I will do, I'll code two examples, factorial and Fibonacci. Factorial is defined by factorial of n equal to n multiplied by what? Factorial of n minus 1. Factorial of 0 is 1. Factorial of 1. 1. 1. All right. Fibonacci is f of n equal to f of n minus 1 plus f of n minus 2. What's the terminating condition for Fibonacci? All right. We'll implement this. And then let me split this part first.